So now that we have unpacked that, we can run this function. You can see that xy with height has those same results. Now here, what we're going to do is right here. Well, we know all of these variables. So that is going to be a tuple of the class as well as xy with height and then the confidence. So in our case, the confidence is set to true, and that's why we have that conf. Otherwise, we'll only be outputting a tuple of the class and the bounding box. So we can run that, and then here, basically, we have our path to our text file, the one that we're going to save. So if we go here, X labels, right now it's empty. But before we run this, I kind of want to show you what this is doing. So let's run it here. So this format specifier is used to format floating point numbers and integers, and it will remove unnecessary decimal places for the integers. And then the R strip is removing any trailing space, especially if we have spaces, extra spaces at the end of the string. So the first line, you can see that it kind of formats these floating points. And then by performing this percentage line, is formatting these values, these floating points, to basically these values here. So both the class as well as the bounding box and the confidence are being formatted. So these will be what gets saved to the text file. So let's go ahead and do that. And then the moment I run this, we have created a text file. So if I go to the folder, you can see that now we have this text file. If I open it, you can see that we have the class, the bounding box, and the confidence. And just for fun, we could do it in our Colab as well. Notice that here in files, we don't have that. And if we wanted to save that text file, we could do it here. So it has been saved. And we can open it here as well. So let's keep going. So given that save image is set to true, even though this is false, and this is false as well, given that one of them is true, I'll step into this. We're going to convert our floating point tensor class to an integer. And then here, high labels is false, so we will not apply that. And high confidence is false, so we will not apply that. So in our case, our label is going to be the name with the class, so the string car, and then followed by the confidence with 2 decimals. So if we run that here, we'll obtain exactly that. Our label, and then followed by the confidence with 2 decimals. Remember that annotator is an object that we created here. And annotator, uppercase, was imported here from Ultralytics.utils.plugin. We imported annotator as well as colors. So we'll focus on the annotator initialization in a later video. But in this video, we're going to focus on this function right here, because we're going to annotate the box according to this function. And don't worry about it too much if you don't understand. We're going to dive deep into what everything means, but let's focus on one step at a time. So if I jump into colors inside plotting.py, you can see that we're inside plotting.py, inside the Ultralytics package. You can see that colors calls a class right here. And this class gets initialized with these hexadecimals, as well as the palette and some others that we're not going to use. And also this class takes 2 arguments as inputs. You can notice here that we have C, which is our class, which is 2, and then we have this set up to true. What this means is that our image, our input image, remember that is coming from OpenCV in BGR format. So here we're indicating that our BGR is going to be true. And this is important so that we can provide the right output. But before we get there, let's try to unpack what this colors class is actually doing. So we're going to jump to our Colab now. And we're going to open this section here. Notice that I've literally copied the class that we have in VS Code here. There are a few parameters that I didn't copy since we're not using them. And let me actually run this. So if we call colors and provide the input to as well as true, what's going to happen is we're going to call this class this class gets initialized, and then by providing the input, we execute the call method, self.palette, we have the I, and then we have self.n. So self.n equals 20. This is for the 20 hexadecimal values here. We'll see how this hexadecimal gets converted to RGB, but for now, self.n is equals 20, and self.palette, it has self.hex to RGB right here, this static method. And these are the values for RGB for all these hexadecimals that we'll see in just a moment. But given that for palette we're calling index2, you can see that the remainder of int2 of 20 with this modulus operator is 2. So in C, we're going to return self.palette and then the index, in this case 2. So 0, 1, 2, we're going to get this output and store it in C. But what this has done before is this function here has converted all these hexadecimals to decimal. And regarding the one that we're interested in, which is this one, 0, 1, 2, this one, this hexadecimal, you can see here, has been converted to RGB. But I think it's worth unpacking this a little bit. For now, just keep in mind that we're providing this index, index2, and it's converting this hexadecimal to this value. And given that we have BGR to true, we will output, in this case, 31 by 112 by 255. We'll return that to color and we'll print that out. So you can see 31, 112, and 255. These are RGB in BGR format.